Hey physics kids, this is episode 2, and in this episode we cover very, very famous physics law called Snell's law. Great law. And it's very simply put. We just talked about index of refraction in the last episode, and Snell's law is n1 sine theta 1 equals n2 sine theta 2. That's it. It's as easy as that. And all this is saying is, if you have a beam of light coming from one substance into another, this substance is all about the n1. This angle here is going to be theta I, or theta incident, or, ooh, look at that. This is going to be, this n1 sine theta 1 is all about this side of it. n2 sine theta 2 is all about what happens to it down here. Now you can always use the Jeep story to figure out how you're going to predict which way it's going to move. And why don't we try one? All right, so let's say we'll do a simple one. We'll do air, and let's do water. We talked about water before. Let's try water again. All right, so we're going to have an angle, beam of light coming down from air into water. Let's say, oh, it's about 40 degrees. So we'll say it's 40 degrees with respect to the normal. All right, what is the n of air? Well, light moves about as fast in air as it does in water. So, as it does in a vacuum, rather. So air is 1.00. It's not exactly the same, but it's pretty close to the speed of light in a vacuum. Water, well, we know water is 1.33. All right, any other thing that you're having, whether it's the medium on top or the medium on the bottom, you can find the index of refractions in your reference table. And if it's something outside that, well, you can look them up online. They're pretty easy to come by because we've studied them all. So what's going to happen here? Let's talk about the Jeep story. Ooh, maybe I could get some green ink to do the Jeep. All right, oh, look at that. There you go. It's my Jeep someday. All right, so there's the Jeep. Here's the tire, here's the tire. Which tire's in the mud? Which tire's in the mud? Clearly, index of refraction that's higher, that's the mud. That's going to slow the Jeep. This tire's getting slowed. This is going faster. It's going to turn the Jeep. So yeah, you know it's going to be bending down this way. But Snell's law allows you clearly to calculate how much it's going to be bending down that way. So we know it's going to bend down, but we want to know exactly if it's 40 degrees angle of incidence, what is the angle of refraction? That angle is this angle right in here, theta r. Okay? I should say theta r, theta angle r. All right? So what is the angle of refraction? It's this law. It's a pretty straightforward law to use. So why don't we put it to the test? So givens n1 equals 1.00, n2 equals 1.33, theta I, or the incident angle, equals, in this case, 40 degrees. Now notice I haven't measured that. I'm just putting these numbers in, and when we start doing this with protractors and all, then you got to measure it very carefully, but you know how to do that. Just saying if it's 40 degrees. And now we can predict what theta r would be in this case. So what would our formula be? That's going to be n1 sine theta I equals n2 sine theta r. Now you can adjust that and say sine theta 1, sine theta 2. As long as you keep track of what's happening where, you're fine. And what is it we're looking for? Well, we're going to be looking for the refraction. So how would we set this up? That would be n1 sine theta I over n2, and that is going to equal the sine of theta r. What's the trick here? Remember, this doesn't equal theta r. it equals the sine of theta r. So when you get all this done, what you have is the sine of theta r. You have to take the inverse sine. And I'll show you how to hit that on the calculator, but that is all you have to do with it. So the S and S then, right, we rewrite N1 sine theta 1. We might be an epidemic, but we're not going to get sloppy with our physics. You're rewriting everything over N2 equals sine of theta 2. Fill it in, 1.00. Notice, no units, isn't that weird? Times the sine of 40 degrees. Remember, that's a unit. That little degree sign, dude, that's a unit. Don't forget it. We divide that by N2, which is 1.33. And you can see, this might be a little complicated. It certainly took mankind a while to figure out Snell's law. But at the end, it's pretty straightforward. Not a challenging law at all. So can you figure out what that's all going to be? I'll get back to you.